Hey guys, this is a review of the TEKS 8.5 A and B. And the first thing I want to talk about is what is an atom. So atoms are the smallest unit of an element that maintains all of the chemical and physical properties of that element. So atoms are made out of subatomic particles called protons, neutrons, and electrons. That is your dictionary definition. An atom is the smallest piece of something, and it still is that thing. It's just a smaller piece of it. So an atom of oxygen, it's still oxygen. If you break it down further, it would be subatomic particles, and those are no longer going to be specific elements. So you have to have a certain combination of subatomic particles for them to be a particular element. For instance, hydrogen has one proton, and helium has two protons, and lithium has three protons, and if it doesn't have three protons, then it's not lithium. And if it doesn't have two protons, then it's not helium. It must have that number in order to be what it is supposed to be. And so protons and neutrons are located inside the nucleus of the atom, and they're tiny, tiny subatomic protons and neutrons. They have nearly the same amount of mass, but their combined mass together determines the mass of the atom. And so if you have one proton, or say two protons and two neutrons, if you have two protons and two neutrons, then you have a mass number of 4. So the protons and neutrons inside the nucleus, those are what is determining the mass number of the atom. Protons and neutrons are similar in that way, that they're the same amount of mass. So how do electrons differ? Because that's the third type of subatomic particle. You've got protons, neutrons, and electrons. Electrons are located outside the nucleus, and they are in an area called the electron cloud. Since the electron cloud takes up space, electrons contribute to the volume of an atom, but electrons are so small that their presence does not significantly change the mass of an atom. So they're very, very small. Protons have a positive electrical charge, and electrons have a negative electrical charge, and neutrons have no charge. So when an atom has the same number of protons and electrons, the electrical charge cancel out. So if you have a positive and a negative, they cancel out. So the atom as a whole does not have an electrical charge. If you have a helium atom with 2 protons and 2 electrons, then you have 0 charge. It's a balanced atom, electrically balanced. Okay. And then to identify atoms, you would use the number of protons located in its nucleus, and we call that the atomic number. And we're going to go over where to find that on the periodic table in a second. But the atomic number is what determines an atom's identity. Like I said, if it has 2 protons, then it is helium, always will be, if it has 2 protons. If it has 1 proton, then it is hydrogen and always will be. So there are the electrons in the outer part of the nucleus. So, or excuse me, you have the nucleus and then you have the electron cloud outside of the nucleus. And so the electrons that are located outside the nucleus are arranged by energy levels in the electron cloud. Each level can contain a certain amount of electrons. There's a maximum for each level. The levels increase in energy as the distance from the nucleus increases. So there's a higher energy level the further out that you go. Electrons are located in the outermost energy shell. Those are called valence electrons and have the highest energy level. So valence electrons can determine the chemical properties of an element. In a chemical reaction, the valence of one element the valence electrons of one element are shared or traded with the valence electrons of another element to create new molecules. Those are the atoms that stick together. So valence electrons will affect the reactivity of an atom by showing how easily and how readily its valence electrons interact with the valence electrons of other atoms. So it just shows that how reactive they are depends upon the number of valence electrons that each of them have. You've got metals and nonmetals react differently. Atoms of metals have a tendency to transfer electrons to nonmetals when they react. Atoms of nonmetals have the tendency to gain or share electrons when they react, and we'll go over that in just a second as well. Okay, so I just want to briefly mention something called ions in case this comes up. Atoms can gain or lose valence electrons, which changes their electrical charge of the atom. So remember, if we had an atom that has, say, 3 protons and 3 electrons, then it is balanced. But if that atom gives up one of its electrons, then it's going to be positively charged because it got rid of one of those negative electrons. And so that's called an ion. If you have something that is ionized, that's what's occurring there. You have unbalanced atoms in that. So if that comes up, that is what an ion is. It is an unbalanced atom. All right, let's go ahead and switch over to the paper here. And let's start out by drawing a Bohr model. Okay, so I have the nucleus right here. And I'm going to say, let's use, I think maybe carbon would be interesting. So we'll do carbon. Great. So now we have carbon. Now, the very first thing that I'm going to draw are the number of protons. Now, I think protons, I think positive, and when I think positive, I think like green. Okay, maybe color them in. Okay, so I have 6 protons. Now, the number of neutrons that I have is going to be based on the atomic mass. Remember, I said that if you have 2 neutrons and 2 protons, then you would have a mass number of 4. Well, in this case, we have a mass number of 12, so we know 6 of those are protons, and the rest would have to be neutrons. Now, the tricky part is you can't have 6.001 neutrons, so we just have to do a whole number. And if it was closer to 13, then we might use 7 neutrons. But since it's so close to just 12, we'll use 6 neutrons. And I'm going to draw them the same size because, you know, they're the same amount of mass, and I want to make sure that I'm not confused by that. Now, in order to have a balanced atom, I'm going to need to have some electrons. So I have positive right now, and so inside of here, inside of the nucleus right now, I have a +6 positive charge to make sure that this is balanced. So I need some negatives. So my electrons are going to be negative. So I'm going to do an electron here, and I'm going to do it in red, and I'm going to make it smaller. So those are supposed to be purple. I don't know if you can tell the difference. So they're always going to be, you can always do 2 on the first ring. You can't do any more than 2 on the first ring. That's the maximum you can fit on the first ring. It's just the way it is, okay? And so we call that the 2-8-8 rule. And we just know that there's going to be able to have 2 here, and you can have 8 here, and you can have 8 here. And if you go to a further ring, if you go to more rings than that, you can have more protons. It just depends, but in 8th grade, we don't go any further than 2, 8, 8. We just go to those 3 levels. So I need 6, so I already have 2, so I need 4 more. So I'm going to do 1, 2, 4. So now I have 6 total. 2, 4, and 6. Okay, so out here I have a -6, and the 2 of those combined, a -6 and a +6, gives me 0, so it's neutral. All right, that's how you draw an atom, a Bohr model of an atom. So let's just do one more. Okay, so first thing I want to do is draw my protons. The mass is, or the atomic number is 3, which means that is the number of protons. And you remember we had a way to know that. We said ape A, P, E. And we said the atomic number equals the protons equals the electrons. Okay, for our purposes in 8th grade, that's what we use, APE. The atomic number equals the protons equals the electrons. So I know that I have 3 protons. 1, 2, and really they should be kind of stuck together, but I'm doing them separate so that we can see them. I got a little, almost a Mickey Mouse there. So now we need to do the neutrons. And there's another little acronym we can use to remember that. It's MAN, M-A-N. And the way you can do that is the mass number minus the atomic number equals the neutrons. Okay, so if I have if I have an atomic number of 3 and I have a mass number of 6.941, then the number of neutrons that's going to show up is going to be kind of strange, right? Because we talked about this a second ago. It's going to be 3.941, but you can't have 0.941 of a neutron. And since you have 0.941 of a neutron, we're going to go up because we have almost 4, so we'll just do 4. We'll say 4 neutrons. 1, 2, 3, 4, and then that's good. And then, of course, I have 3 protons, which is a plus 3, so I need to have 3 electrons, which is a minus. Oh, see, I messed up. You can't have 3 there. Okay, that's pretty much how to do it, guys. All right.